Hello guys, welcome to our YouTube channel Skill Tech 01. Today we will cover the topic SQL, Structured Query Language. And this is one of the most important query language that we use. And one topic comes under it, that is Optimize SQL Queries. So we will see this topic and it will be very helpful for the students, for the job seekers and those who want to crack SQL interview. So this topic is frequently asked, optimize SQL query. So let's see what is it. Some basic uh, key points are covered in this topic. So let's see, optimize SQL query. So what we going to do in it, let's see. So database applications have become a crucial component of many enterprises in today's data-driven world. With so many companies choosing to process and store their data in the cloud, optimizing query has become more important than ever for a company's bottom line. So we will examine some effective techniques for accelerating SQL query performance in this article. There are several ways to optimize SQL query for faster performance, which are discussed below. First, minimize the use of wildcard characters. So the use of wildcard characters such as percentage, underscore in SQL query can slow down query performance. When using wildcard characters, database has to scan the entire table to find relevant data. To optimize SQL queries, it is important to minimize the use of wildcard characters and to use them only when absolutely necessary. So first point is avoid wildcard characters in your SQL query as far as possible. Use it only when it is absolute necessity. Let's consider a query to locate all clients whose last name of the city sorry locate all clients whose last name of the city begins with letter P. For instance, the following query uses a wildcard character to find all matching records. Select asterisk from customer where's last name of city like P%. Okay. So begins with letter P. So this query is made. So this query will work, but it will be slower than a query that uses an index on the last name city column. The query can be improved by adding an index to the last name city column and rewriting it as follows. Select asterisk from customer where last name city is greater than or equals to P and last name less than equals to Q. So this query will use the index on the last name column and will be faster than the previous query. Second, increase query performance with indexes. So always use indexes when necessary. So SQL query can be sped up by using indexes, which enables the database to quickly find entries that fit specific criteria. Indexing is the process of mapping the values of one or more columns from a table to such a unique value that makes it easy to search for the rows that match a certain value or range of values. So to enhance SQL query, you can create indexes on the columns that are frequently used in where, join, and order by clause. However, creating too many indexes can slow down data modification operations such as insert, update, and delete. Consider, consider the trade-offs between read performance and write performance when deciding which column to index and which type of indexes to use. Use the following query to find all orders made by specific customers. Select asterisk from orders table where customer number is 2154. Because the database must search the entire table for the entries that match the customer number, means 2154. So this query may take a long time if the orders table contains a lot of records. So you can make an index on the customer number column to improve the query. Create index. So this is the syntax for creating index. Create index, index name, that is index underscore orders underscore customer underscore number on order table, and this is the column name on customer ID, and this is the index name. This creates an index customer number column on the customer number column of the order table. Now, when you run the query, the database can quickly locate the rows that match the customer number using the index, which can improve query performance. Third one is use appropriate data types. So using appropriate data types for columns in a DB can significantly improve query performance. For example, using an integer data type for a column that contains numeric value can make query run faster than using text data type. Using the correct data type also ensures data integrity and can prevent data conversion errors. Let's consider we have a table that where each row represents the order details of a retail store. The table has columns for order ID, customer ID, order date and order total. So the order total column contains numeric value. If the order total column is stored as a text data type, queries that perform calculation on the order total will be slower than if column was stored as numeric data type. So always use appropriate data types. Okay. Fourth one is avoid subqueries. So subqueries can slow down query performance, especially when used in the where or having clauses. It is important to avoid subqueries whenever possible and use joins or other techniques instead. For example, consider a query that finds all customers who have placed an order in the last 30 days. So the following query uses a subquery to find all the order ID within the last 30 days. So what is happening? Select asterisk from customer where customer ID in select customer ID from order table where order date is greater than equals to date at day minus 30 get date. Okay. So whatever is today's date, we will be reducing 30 from it to get the last 30 days. Okay, and our order date should be greater than or equals to that date. Okay, in the last 30 days. So this query will work, but it will be slower than query that uses join to find relevant data. The following query uses a join to find all customers who have placed an order in the last 30 days. Select now see this example, and this is using the join. Select this string from customer join with order tables, okay, on customer ID basis where order date is greater than or equals to date at day minus 30 get date. So this query joins the customer table with the order tables and retrieves all customer information for those who have placed an order in the last 30 days. This query will be faster than the previous query because it avoids the use of subquery. So instead of subquery, use join to improve the performance. Use limit or top to limit the number of rows returned. So the limit or top clause must be used to restrict the number of rows returned in SQL queries. There will be fewer data to process and return as a result. For example, consider a query to find all customers who have placed an order in the last 27 days. If there are a large number of customers who have placed order in the last 27 days, the query could return a large number of rows. This can be optimized using limit or top. The query limits the number of rows returned to 10. So select top 10 asterisk from customers where customer ID in. Select customer ID from order table where order date greater than equals to date at day minus 27 get date. This query only returns top 10 rows that match the criteria, and this will improve query performance. Another, avoid using select asterisk So using select asterisk statement can slow down query performance because it returns all columns in a table, including those that are not needed for the query. So to optimize SQL queries, it is important to only select the columns that are needed for the query. For example, consider a query to find all customers who have placed order in the last 30 days. So the following query select all columns from the customer table, like select asterisk from customer where customer ID in, then subquery select customer ID from orders where order date greater than dated. Okay. To optimize the query, select statement to can be modified to only select the column that are needed, like select customer ID first name last name from customer where customer ID in, and then subquery. So in this way we can optimize a SQL query. 7. Sorry, use exist instead of in. So use exists instead of and. So value is compared with a list of values written by a subquery using in operators. So okay, what happens in operator? A value is compared with a list of values written by subquery using in operators. However, using in can slow down query performance because it requires the database to perform a full table scan on the subquery. To optimize SQL query, you can use exist operator instead of in. For example, consider a query to find all customers who have placed an order in the last 30 days. So select asterisk from customer where customer ID in, and then you are using a subquery. This query can use in to compare the customer ID, this, this one, with the list of customer ID written by subquery. So this subquery will return the list of customer ID, and those lists will be compared with customer ID. So it will be like comparing each customer ID with the list. So it will increase the query time. So to optimize the query, you can use exist instead of in. So you can also write down in this way, select asterisk from customer, see where exist, select one from orders O where O dot customer ID, C dot customer ID, O dot order date, and in this way you can use it. Okay. This query uses exist to check if a matching row exists in the orders table instead of using in. This can improve query performance by avoiding a full table scan. Now use group by to group data. It is used to group rows based on one or more columns. This can be useful for summarizing data or performing aggregate function on groups of data. However, using group by can slow down query performance if it is used unnecessarily. To optimize SQL queries, you can only use group by when it is necessary. For example, consider a query to find the total number of orders placed by each customer. You can write in this way, select a customer ID, comma, count asterisk as order count from order table group by customer ID. So this query uses group by to group the rows by customer ID and count the number of orders placed by each customer. To optimize the query, you can use a subquery to retrieve the customer information and join it with the ordered table. So you can also write down in this way, select customer ID, first name, last name, order account from customer, and joining it with select customer ID and count asterisk as from a order group by customer ID on ye. So this is the way. Okay, this query uses a subquery to calculate number of order placed by each customer. In here, if you can see here we are using group by customer ID, and then joins the result with customer table to retrieve the customer information. This avoids the use of group by and can improve query performance. Ninth, use store procedure. Store procedure are pre-compiled SQL statements that are stored in the database. They can be called from an application or directly from SQL query. Using store procedure can improve query performance by reducing the amount of data that is sent between the database and the applications, and by reducing the amount of time required to compile and execute the SQL statements. Number 10th, optimize database design. So optimizing the database design can also improve query performance. This includes ensuring that tables are properly normalized and that indexes are used effectively. In addition, it is important to ensure that the database is properly tuned for the expected workload and it is configured for the appropriate level of concurrency. Number 11, use query optimization tool. So there are variety of query optimization tools available that can help identify performance issue in SQL queries. These tools can provide recommendation for improving query performance, such as creating indexes, rewriting queries, or optimizing the database design. Some popular query optimization tools include Microsoft SQL Server Query Optimizer, Oracle SQL Developer, and MySQL Query Optimizer. Number 12, monitor query performance. So monitoring query performance is an important step in optimizing SQL queries. By monitoring query performance, it is possible to identify performance issue and make appropriate adjustment. This can include optimizing indexes, rewriting queries, adjusting the database design. For tracking query performance, a number of tools are available, including SQL Server Profiler, Oracle Enterprise Manager, MySQL Enterprise Monitor. I hope you'd have got an idea about optimizing the query. So these were some key points. I hope you'd have understood about these key points. And if you have any doubts, you can put your comments down on the comment box. Again, we will come with a new videos, new solutions about the technical aspects of the tools and the knowledge. So I hope we will meet with new topic very soon. Till then, goodbye, bye bye.